Hello there, and then welcome to this brand new video. I do hope you are doing well. This is Hub Beyond Numbers, where we learn maths the easy way. Now, in this video, you are looking at factorization of algebraic expressions. Factorizing algebraic expressions. When we talk of factorization, what comes to mind? Factorization simply means you are breaking down an algebraic expression into products of simpler factors. Why do we factorize? Most of the times when we factorize, it makes our expression look simpler. Then it sometimes also helps us to solve equations and also helps us to find factors of some expressions as well. Now, there are some methods we'll be looking at. The first one is finding of common factors. So the first method of factorization we'll be looking at is finding of what? Common factors. After which, we'll then look at grouping of terms. Then there's one we call difference of two squares. And then the last one, quadratic or trinomials. So without much ado, let's quickly look into the first one, which is the finding of common factors. As the name suggests, if you want to use this method, mostly we use it for terms or expressions that have just about two terms. So if you want to use this method, all you want to check out is the terms or the expression I want to factorize. Do they have any term in common? Right? So we can best understand with some examples. So let's look at some examples. So this very one here says you should factorize 6x squared plus 9x. This is what we want to factorize. So this first method, that is finding of common factors, we'll look at the numbers 6 and 9. What is their common factor? The common factor of 6 and 9 is certainly 3. Then we come to the variables. What is their common factor? Looking for the variables common factor is very straightforward. So let me use another ink so that we see that x squared is actually x times x, right? And then this here is just x. So for these two, what do they have in common? They have 1x in common. So for the variables, their common term is what? X. So we write it there as the common factor of the variables. Then now come and ask ourselves, or we would divide each and every term by this factor we have written outside. What this means is we first of all have our 6x squared. So 6x squared. We're going to divide it by 3x. If we divide 6x squared by 3x, what do we have? So 3 divides itself once and it divides 6 twice. X also divides itself once and also divides x squared to give us x. This is covered in the division of algebraic expressions. You can revisit that if you are finding anything confusing. After our division, you see our result is going to be 2x. So you write our 2x here. And what this means is if you multiply 3x by 2x, you are going to get 6x squared. Because 3 times 2 gives us 6, and x times x gives us x squared. Then we go to the next term. In this case, our next term is what? Our 9x. Then we divide once again with what? 3x. So dividing with 3x, as we can see, the x cancels out the x. And 3 divides itself once and divides 9 thrice. So we are going to get plus our 3 over here. Now, this that we have done tells us that if we are to multiply 3x by 2x, we should get this term here. If you are also to multiply 3x by 3, you have to get this over here. So in simple terms, this is how the method of grouping works. Look at the two terms involved, or if there are more than two terms, look at those terms that are involved and factorize out or bring out whatever is common to all of them. Then now you replace this original terms with what? Expressions or terms that will multiply what we have out here to give us this. Let's take some few more examples. Our second example here says let's factorize 12xy minus 18x. So 12xy minus 18x. How do we go about this as well? So as we can see, we first of all start with the numbers. So we have 12 and then 8 here. What is their common term? Or what number can divide them both? That is certainly 6. So we write out the 6. Hence for the numbers, their common factor, their highest common factor is 6. Then we come to the letters or the variables. We have x, y here, and then there's x. What do they have in common? They have an x in common. You see, after which you bring our brackets, then we ask ourselves, 6x, or let's say 6 times what number gives us 12? That is a 6 times 2. Then we come to the variables as well. X times what gives us xy? It is x times y. If you cannot just look at it and say directly, then you can choose to take the 12xy and then divide it by the factorize or the term that is outside. So dividing, we know 6 divides 12 to give us 2, and x divides x. We are left with what our y. So we have 2y. That is what we are writing over here. Minus, we have 18x all over 6x. You can straightforward say, okay, 6 times what gives us 18? I know my 6 times 3 gives me 18. And x times what gives me x? It is certainly 1. We can choose not to write it. If you can't go it this way, then just come here and do your division. X or 6 divides 18 thrice, and x also divides x once. 3 times 1 gives you what? 3. Anyway, it's fine. If you can directly give out your answers without dividing, that is fine. If you want to divide also, that is fine. So let's look at some few more examples. Let's say 1 or 2. And then, so let's look at this example here, which says t to the power 6 s to the power 3 plus 9t to the power 3 s. And we want to factorize it using the method of common factors. So if you look at the numbers, you know there is 1 here, whilst we have 9 here. What is their common factor? Their common factor is 1. And you know for 1, we can choose not to do what, write it. Then we now come to t. There are 3 of the t's here, whereas there are 6 here. What is the common factor? It is 3 of the t. Because as there are 3 t's here, we can find 3 t's also over here as well. So we would write t cube here. Then before that, we look at our s. We have s. There are 3 of the x's over here, whereas we have just 1 here. So how many s do they have in common? It's just 1. You see? So we have s over here. Then we now bring our bracket. So t cube s times what factor gives us t to the power 6 s cubed. If you can't solve that just by looking, you can come and then pick out your 6 to the power s, t to the power 6, s to the power 3, all over. That is what you have here, over your factorized term. You see? And then we know from our division that the 3 of the t's we have here would divide or cancel out the 3 of the t's, and we'll be left with what? 3 more. Better still, you can say 6 minus 3. And for the s also, you can say 3 minus 1, giving us our 2. These are just application of what? The laws of indices. So if you are finding it difficult, you can take time and then go over the laws of indices, and you'll be fine. So we have t to the power 3 s squared. Then plus, for these, we can also do the same thing over here. So we have 9t cube s. all over t cube s. This s here can cancel out this s. The t cube cancels out the t cube, and we are left with just 9. All right. So we would have a 9 over here. And that be it, because there is nothing else for us to cancel out. If you are done with your expression or your factorization and you want to check if what you've done is correct, you can always multiply what you have here, that is your coefficient of the bracket, by each and every term in the bracket to see if that is going to give you what you have above here. So at this point, I'll write down some exercises which you can try on your own to test your understanding. So these are some 4 questions you can try to test your understanding. If you're able to watch to this far and the video was helpful and it's your first time, you can choose to subscribe. So anytime I release any video concerning mathematics, you would also be notified and then learn along. See you in our next video, where we'll be looking at the second method of factorization, which has to do with the method of grouping. Thanks for watching and stay blessed.